Rusting. When we learn rusting in the early year, you have a piece of metal put in 3 different tubs. First one with water, second one with oxygen, third one with water and oxygen. In this experiment, you will find the result always. The water with oxygen, the metal rusts badly. It rusting the most. So it proved that only water rusts medium, only oxygen rusts medium. But water and oxygen combined, it rusts a lot more. Definition of corrosion, rusting. Corrosion is the oxidation of a metal, due to environmental agents. What's meant by oxidation of a metal? Refresh from standard reduction potential table, when the reverse arrow means oxidation. So the rule, reverse arrow, oxidation. The same arrow, reduction, on this double arrow rule. Student, please remember. And rusting means the metal reverse arrows oxidize. Student, please learn this very well, and we will going to use this rule for all our sessions, for many lessons. So oxidation of a metal means rust. So how did you write reverse arrow the way oxidation? And what's the reduction side? So the reduction side is oxygen and water. Oxygen and water. Earlier we explained. So the electron, ion give electron to oxygen and water. So iron and OH, it form into rust and it precipitate. And student, please learn this very well. Precipitation, rust. And this rust can further rust. And this is the equation. But student, please pay attention to the number 2, iron hydroxide. That will be enough for your HSC. The factor promote rusting. Electrolytes in water, that will promote rusting. What's electrolyte? Electrolyte is those positive, negative ion. Example, NaCl. It increases the conductivities of electron in water. So in the picture, if you have a battery and you connect onto the rod, pure water do not conduct electricity well. But once you put a spoon of salt contain positive, negative ion, and it will conduct electricity well. Impurity of the iron also will promote rusting. You will find that the impure iron rusts faster than pure iron. On the top picture, those pure iron flame, and you see that in England. In England, there's a lot of beautiful pure iron grill. And England is a very humid, wet area. But you don't see it rust very bad. But when you see some impure iron, those impure iron, it rusts a lot badly. And it rusts faster. Why? The bottom picture. Pure iron, they are in a nice lattice structure. They all in the very parallel. And the oxygen is not easy to find a weak point it can attack to rust it. But on the impurity, those impurity iron, these structures are no longer in nice line parallel. And those not in nice parallel, oxygen can easy to find the weak point. And those weak point is the place where the rusting can occur. Stress in the iron lattice. Those stress is weakening the iron lattice. So the iron atom, they don't hold strongly together anymore, and where they subject to the rust. As on the bottom of the picture, the corrosion, when the wire being bent a few times, or the nail at the tip or the edge, they will be the place where you will subject to the rusting. Look onto the corner of the right hand picture. In pure iron, in case if you bend it for a few times or you stretch it for a few times, there is a spot of weakening. This weakening, that tiny tear, it will only be detectable in the molecule level. But this is the area where we subject to the oxygen to attack, and you will causing the first rust. Acidic environment. Iron in the acid solution will rust even faster than those we talk water and oxygen. And now let's look onto the standard reduction potential. And why would it rust faster? Iron as oxidized means rust. And which ones will be the reduced? As we say, the first example, oxygen and water will cause rusting. And this is our early scenario. Or there is another option, oxygen with acid. Oxygen with acid in the water, and it will form water. So if you look onto the first one, the top one, how much is the reduction potential? Remember, reverse arrow, you reverse the sign. So you reverse the arrow, you reverse the sign. You same arrow, you have the same sign. And you add together, give you 0.84 voltage. And now let's look onto the bottom one. Same rule, reverse arrow, reverse sign. Same arrow, same sign. Add together, give you 1.67 voltage. This have a higher potential difference. This higher potential difference means you will stronger to react, and so that make it rust faster. Contact with a less active metal like copper. When iron in contact with copper, the iron will rust faster. This forms a galvanic cell. The iron oxidized, copper reduced. What's that mean? If you see on this picture, you see the copper and the iron, and you after a while you see the rust will start onto the iron, and the iron will rust more. Copper don't rust much. And now let's look onto the standard reduction potential table. Iron and copper. Iron on the top more reactive. Copper at the bottom less reactive. So it forms into iron oxidized, copper reduced. So this is the way we write galvanic cell. So ions will reverse arrow. Electron flow to copper. Copper gain electron reduced. Now we have one simple rule. A more reactive metal always will first oxidize, will first rust. Less reactive metal will be spared. So when it rusts, you see iron, as it is more reactive, rusts first. Please remember this rule.